Hey guys, welcome back. We're going to be looking at problem 8 in this video. This is the bungee jumping problem. So this is going to be a hypothesis test problem again. So total, you'll see 3 hypothesis tests questions on the study guide. So you got 3 good examples of the different types of hypothesis tests here. So let's read through this one carefully. We'll make sure we write down any important information as we read it, and then we'll go ahead and perform whatever test it is we need to perform. All right, so it says bungee jumping is cool, right? Wrong. According to the besthealthdegrees.com, about 2 out of every 1 million bungee jumpers die. They just gave us a proportion there, so I'm going to say proportion equals 2 out of 1 million. All right, which I believe you could rewrite as like 2e negative 6. All right, so if you wanted to write that in its decimal form, that's what it would be. That's a lot, and I think it's even more dangerous than those numbers would suggest. So that sounds like a claim. I think it's even more dangerous than those numbers would suggest. So I went and randomly selected 57 bungee jumpers. So we got a sample size, 57, and observed if they died or not after their jump. Unfortunately, I did observe one fatality. So we had one success out of 57, right? We don't want to consider a death a success, but what we're talking about is I observed 57 bungee jumpers and one person died. Okay, so that's 1 out of 57. So we've got a sample proportion, right? So that's going to be p hat, which is 1 out of 57. I want to test my claim that more than 2 out of every 1 million bungee jumpers will die at a significance level of 0.05. So we got a significance level 0.05. So there we go. And we can go ahead and get started on this, right? The claim is that more than, right? So notice the words more than. And remember up here I said I think it's even more dangerous, right? So these are all clues as to what kind of a test we're going to be doing. So our claim is that the population proportion is actually greater than 2e negative 6. Okay, so I'm going to set up my null and alternate hypothesis. So I've got what we're assuming, which is what we got from besthealthdegrees.com, which is 2 out of a million. So I'm going to say that the proportion is equal to 2e negative 6. But I believe my claim is that the proportion is greater than 2e negative 6. Okay, so I'm going to go down. Since I went with more than in my alternate hypothesis, this is going to be a right-tailed test. So I've got everything set up now. I just need to know what actual test I'm going to run. So this particular test is being done on a proportion. So this is going to be a 1 prop z-test. Okay, 1 prop z-test. And I want to go ahead and start finding the value of the test statistic. So I'm going to take my proportion, this 1 out of 57, which in its decimal form is 0.0175. And I'll double check that here. Make sure I got that number right. So 1 divided by 57. Yep, so 0.0175. That's my sample proportion. So I'm going to say 0.0175. I'm going to subtract it from what I expected to get, which is 2e negative 6. And then I've got to divide by a standard deviation. All right, so remember for the sampling distribution for proportions, the standard error was calculated by taking p times 1 minus p all over the sample size, and this was all inside of a square root. Okay, so I have to do this calculation first so I can get the bottom of my calculation for the test statistic. And the p that we're going to be using is the 2e negative 6. All right, this is going to be kind of weird, but we're going to do 2e negative 6 and then 1 minus 2e negative 6 all over our sample size, which was 57. And I'll throw that inside of a square root. Okay, so I'm going to run that calculation. Let me show you how I do that in my calculator real quick. So remember we did 2 divided by 1 million. That's 6 zeros, by the way. And there's our 2e negative 6. And then I'm going to do 1 minus that answer. Okay, so there we go. We got our two things. So I'm going to do this 2e negative 6 times the 1 minus, just like that. And let's see what we get there. And then I'm going to divide that by 57. That's my sample size. So there's that. And then I'm going to square root it. And we get 1.87 e negative 4. Okay. So there's my thing, and that's what's going to go on the bottom here. So 1.87 e negative 4, and this will be a z value. All right, so this is how many standard deviations away we are from what we expected to get. And if I do this correctly, you should get 93.414. Right, so that is a lot of standard deviations away. 93.414 standard deviations is extremely rare. And in fact, I'm going to spare you the calculation of the p-value. I think you know that if you're 93 standard deviations away, the probability of that happening is simply going to be 0 plus. But if you must do the calculation, right, you can draw your normal distribution. Right, and 93.414 is going to be way over here on the right-hand side. And you're looking for the area in this tail. All right, so you're going to have to use a normal CDF for that. Like I said, I'm going to spare you the calculation, but that's at least the setup for it if you want to do it. All right, so we got a p-value of 0 plus. It's next to impossible. All right. So what conclusion should I reach? So I compare my p-values. So I do 0 plus compared to my significance level of 0.05. 0 plus is clearly less. So we're going to reject the null hypothesis. And then I'm going to write my conclusion in the context of the problem. Okay, so there is sufficient evidence to support the claim that the proportion of bungee jumpers who die is greater than 2e negative 6. All right. Or 2 out of 1 million. And our evidence would suggest that it's greater than, because I observed 57 people and one of them did plummet to their deaths. So based on my data, it happened in much less than 2 million trials. Okay, so let's make sure we describe a type 1 and a type 2 error here. And let's see, so remember a type 1 error is rejecting the null hypothesis when it's true. Right, so in the context of the problem, that would be assuming bungee jumping is more dangerous when it isn't. Right, so in other words, I'm assuming that the proportion is more than the 2e negative 6 when it's in fact not. So you might go ahead and assume that bungee jumping is too dangerous and you miss out on going bungee jumping. Okay, so that's what a type 1 error would lead you to do. You assume that it's more dangerous than it is and you choose not to go bungee jumping. All right. So for a type 2 error is where we fail to reject the null hypothesis when it's in fact false. Okay, so in the context of the problem, it is assuming bungee jumping is safe when it isn't. Okay, so by failing to reject the null hypothesis, I would be going along with the assumption that 2 out of every 1 million people who bungee jump are going to die, when in fact more than those 2 people are going to die, right? So if I stick with that assumption, I might make the decision to go bungee jumping when it's not safe to do so. All right, so this is written in a way that, you know, we're making an assumption about how safe it is or how dangerous it is. So I'm assuming that bungee jumping is safe when in fact it is more dangerous than it appears. All right, so there's a number of different ways to kind of say that for a type 2 error. I'm interested in how you word it for that type 2 error, but you could go very technical with it and say something like this. Failing to reject the proportion of bungee jumpers who die is 2e negative 6 when it is greater than 2e negative 6. So we should have rejected that the proportion is 2e negative 6 when, you know, it is. So This is a much more technical way of describing that type 2 error, and you might be more comfortable with doing that because it follows that template of the fail to reject or reject, where this one is much more relaxed. It says the same thing, but it might be a little bit harder for you to word it that way if you're struggling with the type 1 and type 2 error definition. So this is a more safe way to do it. This is a more relaxed way, but a little bit more risky if you mess up some of the wording. Okay, so just some things to consider. All right, we're going to wrap up this problem by looking at the calculator and how to run this same exact test on the calculator without doing it by hand. So this one was a one prop Z test. So if you go to stat and you go over to tests, oops, not that test, we want stat, test, and you're going to go down to the one that says one prop Z test, which is option number 5. There we go. Once your assumed proportion, so remember that was 2 out of 1 million. That's 6 zeros. And then it wants the number of successes. Again, successes might be a bad word to use for this particular test because it indicates that someone did plummet to their death while bungee jumping. So we had one person who did that. And then we had 57 observations or 57 trials. So that was our sample size. We are doing a right tail test since our claim was that it was greater than the 2e negative 6. And we're going to go to, we're going to go to calculate and just make sure that our numbers line up. So let me go back up here where we calculated our test statistic and our p-value. Go. And let's see what we got. So we got 93.64. We got 93.414. Again, that's probably just a rounding discrepancy. Remember, we didn't even bother running the normal CDF because we just assumed it would be 0 plus. And in fact, it is here. If we take a look at this, they literally got 0 because the probability is so small the calculator can't even detect it. So we did good. All right. So that's your calculator test for you. All right, guys, that's it for problem number 8. Good luck. Tune back in if you need help on other problems.